A system of equations or inequalities is two or more inequalities that will share a solution set or some solutions. The same rules for just graphing one linear inequality still apply. So if I have a less than or a greater than sign, what kind of line is graphed?
Oh, dotted line.
Dashed line. Okay, if it's or equal to, the line then becomes solid. Same rules. Okay, and then similarly, if you are shading for an inequality that is either less than or equal to, your shading will be below the line. And if it's greater than or equal to, your shading will be above the line. Okay, now your solutions are not just the shaded area anymore. You've got two inequalities, which means that your solutions are in the double shaded region, or on a solid line binding the shaded region, the double shade. So when you look at the line, and if it's double shaded in that section, the line that's attached to it. So like half the line could be, but the other half is not. When we get through the first one, it'll make total sense because I'll show you. All right. So example one, if I'm going to graph it, what's wrong with it?
It's not
slope.
It's not slope-intercept form. So the first thing I need you to do for all examples actually is go through and just solve all of them for y. That's going to save us a lot of time later. So solve example 1 through 4, solve all of those inequalities for y. Alright, so my two inequalities for example 1 are y is
less
than 2. Okay, and y is x minus 1. Good. Alright. Example 2, my first inequality turned into y is negative 2x plus 3. Very good. And the second one, y is less than. Very good. Example 3, the first one, y is greater than or equal to 3 over 2x plus 1. And the second one, y is and then top one on 4 didn't change. But what is the second one? Y. Okay, so here's what we're going to do. You have put them all into slope-intercept form. So now we can just graph away, right? I am going to do the first two with you. All right. So my first line, line. Y is less than negative 3x plus 2. Solid or dashed? Ooh, dashed. It's not equal to. Above or below? Below. Okay, so plus 2, down 3. Okay, so there's my line. Use your y-intercept. It is shaded below.
Is this where you use the different color?
Or shade lightly, yeah. Okay.
Can I use a colored pencil?
Sure. Everybody got the first one graphed? You good? So that's not different than what we've been doing the past couple of days, right? It's just the addition of that second line. So now, when I graph the second line on there, is it solid or dashed?
Solid.
Solid. Above or below? Above. Okay. So when I shade this line above as if the other one wasn't even there, what happens? Well, mine turned green, right? Because I overlapped some yellow shading and some blue shading. So my section turned green. The green section, or the double shade, is the solution set. Okay, now, Sam, remember you asked me what does it mean when I'm saying that the solid line binding the double shaded? So see how this solid line goes through the graph? But the only part that could be your solution could be this part because it's attached to that double shading. Does that make sense? All right, so let's check some solutions. 0, 0.
Yes.
It's inside the double shade. That is a yes. 0, -4. No, only in the yellow. If it only works for one, it doesn't work at all. 1, 4. -3, 3. Yes.
Graphing is the best thing.
Okay, so does that make sense? It's the same idea as yesterday, except now that there's 2 graphs instead of 1. Alright, let's do the second one together. My first line, y is less than or equal to -2x plus 3. Solid or dashed? Solid. Above or below? Below. Take a second, get your line graphed on there. My second line solid or dashed? Dash. Above or below? Below.
No.
So 0, 0. No. Works for one, but not both. 0, -3. Yes. 5, -1. No. -2, -3. Oh, it's on what kind of line? A dashed line, so that does not work. Okay, so we have example 3 and 4. They're already solved for y, so go ahead and try those 2 on your own. Okay, check your graphs. How'd you do? Good. Was 0, 0 a solution to 3? No. 3, 5? Yes. 1, 2, 3. 1, 2, 3, 4, 5. It was on the line, wasn't it? 2, 4?
Yeah. On the one.
We need to check 3, 5 just to make sure. 0, 3? No. Let's check 3, 5. How do you think you can check 3, 5? Not with the calculator. Put it into the inequalities. 3, 5. What is x? 3. What is y? 5. So if I have the first equation, 5 is greater than or equal to 3 halves times 3 plus 1. Can you use my handheld? Thanks. 3 halves times 3? 1.5 times 3? 4.5. 4.5 plus 1? 5.5. Is 5.5 less than or equal to 5? No, so we were wrong. The graph might have appeared like it was, but that is not a solution. Glad we checked. Okay, so if I go in and check my inequalities and one works and the other doesn't, is it a solution? No, it has to work for both inequalities. Okay, and then the fourth example, 0, 0. Was 0, 0 a solution? No. 0, negative 4? No. 2, 2? Yes. 5, negative 1? Yes. Very good. All right, flip it on over. I've got two sets here, example 5 and example 6. If we ignore the inequality symbol for a second, and I just look at the equation itself, is there anything special about those equations?
Same slope.
Same slope, different line of. What does that mean? They're parallel. What about example 6? They're parallel. Two different things are going to happen though. So with your table group, y'all need to graph these and explain, be ready to explain to me how they're different. Okay? So do 5 and 6 and then explain how they're different. How are they different?
First one has no intersection.
Okay, so when you graph the first one,
Second one.
it's supposed to be dashed. Alright, so you graph the first one, it was shaded below, and then the other one was shaded above. So how many solutions were there?
0.
No solution. So none of these worked. Okay, the other one,
They share the same space.
they shared some space, not all of the same space, right? X minus 2. And it was above. And then x plus 4.
Wow.
And it was below. Did they have anything in common though? The two questions, example 5 and example 6? The slope, they were parallel. Did they both have the same inequality symbol?
No, so they have
No, the inequality was opposite for both. So can I say that every time I have parallel lines, there will be no solution?
No.
No, it is a case-by-case basis. So now, was 0, 0 a solution for this?
Yes.
Yes. 0, 4? Yes. 1, 0? 8, 1? No. Okay, your task now, you need to check the solution for 7 and 8 And then for 9, 10, and 11, they're hard to read, so you're not writing the system, but you're determining if the given point is a solution, and if it's not, find me one that is. So you're not writing the inequality, just determining yes or no on the solution. If it is not, find me a new one. Remember, when you're checking, the point has to work for which inequality? Both.